Let's do this thing. We're going in cold.
Or like chilly, at least. I don't know if it's like ice cold.
Well, let me stop the share real quick so that we can say hi to everyone. Hello, everyone.
Hello. Welcome back.
Welcome back. Mrs. Contreras has returned. You have taken off your wizard hat. All right, let's go back. We are solving more trig equations, but this time with identities. So we've solved before. Now the equations are just, I wouldn't say harder. Just there's more going on. We have more in our brain to kind of juggle.
Yeah. More tools to tackle this way.
Yeah. You had the link, right?
Yep.
Cool. The date is something. And the period is a number. A natural number. All right. Cosine 2x is equal to cosine x. I feel like there's an obvious answer that we can just like write down.
Well, it's not 0. Is it? Oh, 0 would work.
Right? Because cosine of 2 times 0 is cosine 0. And cosine of 0 is cosine 0. So 0 is an answer, but we want to be able to solve this analytically, not just like look at it and know the answer. But you could probably like reason out some other answers. I think 2 pi will also work.
Because that's 0.
Yeah, well, if you plug in 2 pi into the first one, you get 4 pi. But 4 pi is the same as 2 pi. So we're looking for numbers that when you multiply it by 2, it still outputs the same cosine. Huh. Would pi over 2 work?
Well, then you would have cosine of pi equals cosine of pi over 2. And I don't think that's true.
So we need to solve this analytically. So when solving something analytically, we need to make all of the trig functions in our equation the same. So in the past, we turned cosines into sines and cotangents into cosecants just so that we could have the same function repeating itself throughout. Sometimes it turned into a quadratic, but that was okay. Here, our arguments are different. So we currently don't have the same function appearing constantly. We have a function and then it's same function, just compressed by 2. So how
can we rewrite it?
Rewrite it. So elaborate a little bit.
Like cosine of 2x, right? That's cosine, cosine, sine, sine, sine. So cosine squared minus sine squared.
Cosine squared minus sine squared. We are halfway there. I really like what you did because in the last video, we went through a bunch of identities, but really all of those identities are just cosine, cosine, sine, 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 simplified and stored for like convenience sake. But really, if you don't remember the identities, cosine, cosine, sine, sine, sine is the money. If I wanted to continue so that all my functions are the same, what should I do now?
Can we take that sine squared and replace it with, what is it, 1 minus cosine squared?
And I'm going to make sure I'm using all my parentheses as appropriate. 1 minus, cosine squared x is equal to cosine x. And then doing a little bit of algebra, distribute that negative to both the 1 and the negative cosine squared. We get 2 cosine squared x minus 1 is equal to cosine x. And this was one of our identities from last time. Cosine 2x is equal to 2 cosine squared minus 1. But just rederive it every time. Who cares? Like 30 seconds of your life, not wasted. All right.
Remembering, or you're like reviewing all the things that you've learned before.
I actually have a really cool like activity where we go through all of the identities and the only one I give you is cosine, cosine, sine, sine, sine.
Nice.
Like I remind you, okay, so we did this geometric proof that took a little bit of time. Now prove all of the important formulas in trig. And it's actually much easier than one might think. All right, let's keep going.
Okay.
2
Can we move
squared.
the cosine over so that we end up with something we can use some?
Yeah. Minus cosine x minus 1 equals 0. You know what? I'm going to use the power of Kami to move this over now. I liked it in the middle as I was working, but we're going to need more space.
Mm.
Cool. So you want to U sub. We're going to say, sorry about that. Cosine x is equal to U.
Cosine equals U. So then, and I'm going to start up on the
You're
side
writing on
where
the
we
top?
have 2u squared minus u minus 1 equals 0. Boom.
Boom.
Okay.
Factoring time.
Okay.
This is a quadratic. All right. I
So
always need to write those little things. I'll let you take this, but when I do it, I have to write 1, 2, 1, 1, and then like do the cross.
1, 2.
I've trained my brain to do it, so I can't do it without it. Maybe that's a bad thing.
Okay.
Now, that's my
So
preferred method.
So we have 2 times 1, and then 1
Like that,
times
yeah, there's only one option here, right?
1. Yeah, because it's a 1, and the only way to multiply
It's kind of
that
nice.
1.
Now we just
And
need to
then
figure out where the plus and minus go.
I think we need the negative on the 2.
Mm-hmm. The negative on the right one, so it hits the 2. Yeah.
Mm-hmm.
Boom.
Yes.
We
Thank you
factored.
for saying that. Yep. Factored. Cool. So
Right.
that means that we need u is equal to 1 or u is equal to negative 1/2. Which means, and I'm just going to be really lazy and erase those, or efficient.
No, I don't think you're being lazy. I think you're using the technology that you've been given. Kami's so great. Like, it makes erasing so much. You know, remember the old days when you erased and there was smudge marks? Those days are behind us. We have moved into the future. I spent good hard-earned money on good erasers because I hated smudge marks. You know, like the poly what's it called?
Yeah, the ones that are like it's like kind of longer, and it's little like it's got like a blue like case thingy.
A case, yeah. I don't have one in front of me because I haven't needed one in over a year. All right, so we need to know when cosine is 1 and when cosine is negative 1/2. I know when cosine is 1.
Okay.
Because we established that at the beginning. That's 0 and 2 pi, right? 0 plus 2 pi k? 2 pi k?
2 pi k. Cool.
Those were the answers that we were intuitively able to come up with.
Mm-hmm.
So you plug in any multiple of 2 pi. When you multiply by 2, you're still just on the same spot in the unit circle. Negative 1/2 is the more difficult one.
Mm-hmm.
Right. We're looking for the x coordinate is negative 1/2. It's going to be in the second and third quadrant. 2 pi over 3 and negative 2 pi over 3.
2 pi over 3. I just sketched a little circle. This is not to scale. What did you say?
2 pi over 3 and then either 4 pi over 3, but I rather think about it as the opposite, negative 2 pi over 3.
So Plinus.
Plinus, yeah.
Plus.
Plinus and Lucy. I can't do the dance, isn't? Yeah. Oh my God, I'm so sorry.
All right. Cool.
And then if you think about it, I said 2 pi and 4 pi, 2 pi over 3 and 4 pi over 3. 4 pi over 3 is the double of 2 pi over 3. If you plug 2 pi over 3 in, you're going to get 2 pi over 3 on the right hand side, 4 pi over 3 on the right hand side, and those are equal. Same with negatives. I think 4 pi over 3 and 8 pi over 3 will also work.
I just got really excited about our colors because you are blue in your like little Kami dot is blue, and you're writing in blue, and I'm green for my little Kami dot.
Oh my gosh. We are color coding this. So pretty people great. Have been in their shared Kami dots highlighting the numbers that they want to do. The teams will collaborate at the beginning, figure out who's going to do what, and then they'll go through and highlight the number. It's really nice. I'm actually going to do it real quick so that people can see how to do it if they choose. Like, I'm blue, right? I'm going to make my stroke like 10, and my transparency, if it ever works. Let me use my mouse. I didn't mean to do that. Make my transparency like really, and then just go boop.
Oh, nice.
And I'm doing number one. So with that said, I forget where I was going with this.
But it's cool. Good use of technology. Thanks.
Right. No, I remember what I was going to say. Everyone should make the color that they choose, the color that they've been given by Kami in the bottom right corner.
Mm.
All right. There we go. We have our answers. And we use identities. What identity did we use? We used the double angle formula for cosine. And instead of just memorizing a bunch of formulas, we just use cosine, cosine, sine, 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 and then rederive those formulas. That's honestly what I do for the next one. Ah, you're so well composed. I don't know how you get the crab in there without me noticing.
You talk a lot, Mr. Kirk.
I do. That's true. I do. Yeah. Okay. We only have 2 problems for you guys today. So we'll keep moving. Sine squared x plus 2 is equal to 2 cosine squared of x divided by 2.
Mm.
Same thing. We have a cosine squared and a sine squared. We need one of them.
Right. I mean, I guess we did the other one in terms of cosine, so we can do this one in terms of sine.
I think so. And also sine's the one where the argument is not complicated. It's just x. We want to use our half angle formula. I don't want to try to remember the half angle formula, so let's rederive it real quick.
Cool.
Cosine squared x over 2. So we have cosine, cosine, sine, sine, sine. And then, so cosine 2x is equal to cosine squared x minus sine squared x. We just did that problem. And we have a cosine squared x. So let's write our identity in terms of cosine squared. I'm gonna continue to do what you did in the last problem, right? This is 1 minus cosine squared x. And then I'm gonna get 2 cosine squared x minus 1. I currently have that cosine 2x is equal to 2 cosine squared x minus 1. And I want a formula for cosine squared x divided by 2. I'm going to solve for cosine squared x. Add 1. Divide by 2. 1 plus cosine 2x divided by 2. And we are very close to getting our identity for cosine squared x divided by 2. Do you see what to do?
Is it as simple as doing a use of?
That's a simple. I was about to, if you didn't know what to do, I was going to say, what did you do in the previous problem? I swear these 2 problems were not chosen to make the second problem easier, but you have chosen ways to do the first problem that have like activated our brains for the second one. I love that. Yeah, it's as simple as a use of. Let's just replace x with x over 2 and replace 2x with x.
Because it's an identity, right?
Boom. And in the last video, we talked about the reduction formulas, where you take a square trig function and you turn it into a not square trig function. And so those are useful formulas, especially when you get to a unit in calculus that deals with polar coordinates. I'm not going to get into that right now, obviously. So that reduction formula is a good one to know, but also some u substitution. Let's just have both of our angles. And then now we have a formula. Cosine squared x over 2 is equal to 1 plus cosine x divided by 2. Or you can use that song that I did not sing in the last video that I linked to in the chat to remember the half angle formulas, but I'm not a fan. Sine, oh, it looks like
that we did on the side.
What?
That was a lot of work that we did on the side. but I think it was really helpful to like divide out our page like that. Like to have like this is what we are like thinking through, and then this is us attacking this problem.
I feel like that happens a lot in math, right? Especially like proof writing, where oh look at that. We're actually not going to turn it into science, I don't think. You want to make the sound effects?
We should. Because that sine squared becomes a cosine very nicely. Oh, it's a sine. Yeah, sine squared is going to be 1 minus cosine squared. So then we end up with 3 minus cosine squared.
I don't really need the parentheses there, but
it's like responsible.
I think so. Yeah.
Yeah.
I changed the nib in my pen, but I think it's the pad. I think I just write too hard.
You want me to take over?
Yeah, sure.
All right, so we got what 3 minus cosine squared x, and I'm just gonna move this over.
Wait, is it going to be 3? 1 plus 2. Yeah, it's going to be 3. I'm sorry.
And then we'll take away the 1 again.
Yep, that's
so
what
I was unnecessary.
Yeah.
All right, cool. So then we end up with again 2. So I'm gonna do negative cosine squared minus cosine x plus 2 equals 0. Boom, boom. And then
using your wizard skills.
Yes. So then what can we do from there, Mr. Kirk?
I would like to flip the sign everywhere. That's just a preference. Are you cool with that?
Absolutely.
Multiply both sides of this equation by -1. And while you do that, I'm going to add a page so we have a little bit more room. Another reason. Remember back in the day when you ran out of room on the page, you had to either flip it over or stand up and go get another sheet of paper.
Yeah.
Or reach and grab one if you're close. Oh man, we live in the future.
You can also, like.
Although this is taking a really long time to load a new page, so that's not good.
This seems like it's taking longer than standing up and grabbing a new piece of paper.
Come on.
You can also just resize what we wrote.
We could have. Oh, remember back in the day when you wanted to resize your work, you would erase everything and then start from scratch from the beginning.
Do you ever resize your work? All right. So
I get one more back in the day before the end of this video. All right, that's a quadratic.
All right, cool.
Okay. It's going to be the same thing where it must be 1 and 1 and 1 and 2. And we just have to figure out the negative sign. This is basically the previous problem. I love math.
That is pretty cool. Boom. And so we get what? Cosine.
I like that you're not doing U sub this time. That's nice.
Yeah, I just didn't feel like it. Yeah. I don't see the second page, so I can't use it. So I'm just continuing work up there.
Do you want to maybe hit refresh? Try ahead and refresh. These are all, I don't think this is a bad thing when we have to figure out Kami on the fly.
Hey, totally worked. Very cool. But I already started up there.
Someone was having saving issues recently in Kami. It said at the top offline, and I'm like, I just talked to Verizon the other day, and they told me to solve my problem for Verizon, I had to clear my cookies. I'm going to tell this student to clear their cookies. They went and cleared the cookies, and then it worked. They started saving. So there's a tip for everyone. When Kami's not saving, clear your cookies. It's in the settings in Chrome.
Does that work? -2.
Oh, I love when cosine equals -2.
Because that's not a thing, right?
No. I find immense satisfaction when the answer is undefined.
Undefined. Boom. And then when is cosine 1?
If you look up in the dictionary undefined with 4 eyes, you'll actually see cosine x is equal to -2.
with the pictures of our faces looking really silly.
Look it up.
So cosine is 1 when what we have 0 plus 2 pi k.
Yeah, cosine is 1 only once per period. Unlike, and cosine is -1 once per period, but all other numbers, it happens twice per period. So we got lucky in this assignment.
That makes sense, right? That we have, because it's at like it's like your starting point. It's like the top of your, yeah.
Sound effects. There we go. Boom. And we never really did any squaring. So I don't think we need to check our solutions for extraneous solutions. Yeah, we never raised a red flag. We never did any irreversible operations. But I think we're good. I think we got our answers. We got undefined and 2 pi k. Nice. I don't really feel like checking them. Do you want to check them?
Students can check our work and then they can yell at us if we're wrong.
Yeah. We could. I have an idea. Can we do something real quick? Can I graph these on Desmos and see if they intersect at where? That's like the best way.
That's what I would have suggested the students do.
Sine squared x. What is the right-hand side? Do you still see it?
+2.
+2. And what is the right-hand side?
And then 2 cosine squared of x over 2.
X divided by 2.
There you go.
There we go. They intersect at 0 and 2 pi. Let me, for those who didn't know, you can change the step. I want to change this step on the x-axis to pi.
Beautiful.
And then 0, 2 pi, 4 pi, etc. Boom.
Nice.
Excellently done.
I feel like there should be another art project using trig functions because it's like, get like beach vibes.
You heard it here first, everyone. There will be an art project coming soon to a trig class near you.
It's not even fair. I'm not even grading them.
What?
I'm not even grading them. It's not fair. Just like,
yeah, but
we should do this project.
I'll send you the link and you can see everyone's artwork.
Nice.
Yeah. All right, let's close this one out. Not too long of a video. We bantered a little bit, so it got a little longer than it needed to be, but it won't be tremendously too long. Any wise words for the students since you last saw them virtually through a YouTube video?
Always wash your rice.
Always wash your rice. That is something that has been a game changer for me lately. I didn't do it probably 6 months ago, but I started washing my rice before I cook it, and it's significantly better. Thank you for that tidbit. All right, Let's close this one out.